Chapter 12, Crystalline Solids. Exercise 12.39. Silver has density of 10.49 grams per cubic centimeter and crystallizes with the face-centered cubic unit cell structure. Calculate the radius of a silver atom. How do we calculate the radius? Well, we'll use this equation for the face-centered cubic unit cell. The length of the face diagonal is the edge length L times the square root of 2. It's also 4 times the atomic radius. So if we know the edge length, we'll compute R easily, because you can see R is equal to the edge length times the square root of 2 and then divided by 4. This would be the atomic radius. Now how do we compute the edge length? Well, it's simply the volume of the cube to the power of 1/3. That's the edge length. Now how do we get the volume of each cubic cell? It's going to be the mass divided by density. I think we have the density 10.49 gram per cubic centimeters. So we'll do that. Here's the density in grams per cubic centimeters. And now what's the mass? In the face-centered cubic cell, there are 8 corner atoms and 6 face atoms, but only 1/8 of a corner atom is inside the cell. Only 1/2 of a face atom is inside the cell. So to count the number of silver atoms inside the cell, we have 8 times 1/8. That's the number of corner atoms, and then we have 6 face atoms times 1/2. Here we have 1 plus 3 equals 4 silver atoms inside each unit cell. What's the mass of each silver atom? We'll find the molar mass of silver, which is 107.87 grams per mole. So we have to divide this 107.87 grams by the Avogadro constant. This way we'll get the number of the mass in grams for each silver atom. And now we have the answer in centimeters. This is just because this 10.49 is in gram per cubic centimeters. So over here, when we use mass in grams divided by density in grams per cubic centimeters, we'll get the volume of each unit cell in cubic centimeters. To the power of 1/3, we'll get the edge length in centimeters. And then multiply by square root of 2 divided by 4, we'll get the atomic radius in centimeters. We need to convert the centimeters to picometers. Each centimeter is 0.01 meters. So now you see this value in meters, and each meter is 10 to the power of 12 picometers. Now we converted the value to picometers, 145 picometers. As the radius of a silver atom in picometers. Now let's review the equation. So first, we need to know the edge length of 1 cubic unit cell. How do we get the edge length? It's going to be the cubic root of the volume. But how do we get the volume? It's going to be mass over density. Mass divided by density is volume. So we have mass on top. On top we have 4 silver atoms times the mass of 1 silver atom. We get the mass of the 4 silver atoms inside the cell. On the bottom, that's the density of silver in gram per cubic centimeters. Therefore, we get the volume here in cubic centimeters. We take its cubic root to get the edge length in centimeters. And that's, again, the edge length. Because the square root of 2 times the edge length equals 4 times the radius. Therefore, the radius of a silver atom is the edge length times the square root of 2 divided by 4. So over here we have now the atomic radius in centimeters. Multiplied by 0.01, we changed the unit from centimeter to meters. And then 10 to the power of 12 is to change the unit from meters to picometers.